Okay, live from the Weather Co-op studio. I am Jay Dubensky here with an update on, drumroll, Hurricane Ernesto. And I mentioned this over the weekend. If you're one of those people that likes weather and has been thinking about weather for years and years, you probably remember the name Ernesto. And you are correct because Ernesto was also a hurricane in 2006. And the only reason that it was still possible to use the name Ernesto this year is because that name was not retired in 2006, because the hurricane did not cause a significant amount of damage and was deemed a retired name, not deemed by the National Hurricane Center. So the name went back into circulation and happened to come up this year. So here we have Ernesto, I'll call it 2.0. I think I said that over the weekend. And this version of Ernesto is much stronger than what we saw in 2006, where the storm moved across Florida, then came back out in the Atlantic, and pretty quickly made another turn back inland, and then went up the East Coast and dissipated. Only made it to minimal hurricane strength, but did cause a little bit of damage, across Puerto Rico and Cuba and then Florida, but not enough to be retired. So here we have Ernesto 2024. And right now we're dealing with a storm that, as of the last update from National Hurricane Center, was still hovering around 100 miles per hour in terms of the max sustained winds. The minimum central pressure was at 989 millibars. So, it's actually fluctuating up a little bit, down a little bit. And I'll show you why in a moment, why that's happening. But I have this graphic up that I'm starting with. And by the way, for those of you on my Twitter feed, X feed, if you follow the Weather Co-op feed or follow it on IG, follow it on Facebook, follow it on YouTube, you can see the graphics that I have on display here for those who are watching on the Weather Co-op pages. So it, kind of hard to flip that around, but if you want to look on those others and, simultaneously watch, terrific. So we have the current placement of Ernesto as a Cat 2 hurricane. Now it's about 180 miles southeast of Bermuda, and it is moving to the northwest at 14 miles per hour. Picked up a mile there from the last report. And what we think is going to happen now, we're reasonably certain of this, is that Ernesto is going to peak off where it is right now and then slowly weaken a little bit in the short term, approach and then cross very close, if not right over the island of Bermuda, and then continue north-northwest, heading up into the open Atlantic, and for a brief time, possibly intensify, as it's still going to be over very warm ocean water at that point, and eventually will begin to transition into an extratropical cyclone as it heads up into the North Atlantic and clears out over the Canadian Maritimes. Now, this is one of those storms that will end up eventually making its way across the Atlantic in all likelihood and potentially impacting Great Britain or some point next week. So we'll have to watch that as well because the storms can have an impact there. But in the short term, we have a very strong, Cat 2 hurricane here that's going to impact Bermuda. The major impacts are going to be from the wave action and the surge, and then the rainfall, which will be probably in that 6 to 10 inch range based on the forward motion. which is a lot of rain in a short period of time, no matter how you slice it. But the wave action is going to be significant. You know, we've seen this propagation of waves out from the circulation of Ernesto. And by the way, the tropical storm force winds extended, I believe it was 275 miles from the center of circulation with the last report. So you have this large wind field that's developing with Ernesto, and it's pushing the wave action farther away from the center with time. And the waves are already affecting Bermuda and are already affecting the Turks and Caicos, which Ernesto has moved far northward from, but the wave action is still propagating outwards. So Turks and Caicos are feeling it. The Outer Banks of North Carolina are beginning to feel that, and the entire East Coast will get in on that action over the next few days. So it is not a good day to go in the water. It won't be a good weekend to go in the water. If you're planning a nice late summer, you know, mid to late August beach trip for the weekend, just stay in the beach. No need to go in the water. It's not that kind of a weekend. And as we said before, if you're going out on a boat, I just wouldn't recommend it. You know, even for those who have been out on the water a lot and have great sea legs and don't really get motion sickness out on the water, we're talking massive waves. I mean, the closer you get to Ernesto, you're going to be dealing with 30, 40, 50-foot seas. So it's not going to be the type of thing you want. And those are large swells. Even the hardiest of lobster men and fishermen who work out of those ports, you know, out of Massachusetts, et cetera, even they don't want any part in that. So, you know, don't make yourself a statistic. As we go through this graphic here, there are a couple of interesting things to point out with it. First one would be the proximity of the path of the Ernesto to Bermuda. Yesterday, the track had the center passing to the west of the island, which would have meant that the strongest core of the winds would have affected the island directly. Now that track has shifted a little bit eastward, we're looking at more of kind of like a direct bullseye hit from the center of Ernesto on Bermuda, which means the strongest of the winds will pass to the east of the island. That's a good thing. But given that it's a direct bullseye, it will get a large majority of that wave action and surge on the island. Now, Bermuda is built like a fortress. I mean, if there's any island that's made to take a hurricane, it's Bermuda. And the people that live there are very hardy and very well prepared for things like this. But it's still, you know, 100-mile-an-hour hurricane. So it will cause some damage there. And it's really the first hit that they have had this season. So it's always the toughest when you have that first initial hit. Now, moving ahead, you can see how the track looks to be taking the storm up over, well, past the coastline of Nova Scotia and out over into the Canadian Maritimes, and then across the Atlantic. So we'll see what that does over the next few days and how true it holds to that forecast. Now we'll look at something that we can put together here at Weather Co-op, kind of exclusive in terms of what we can produce for you. This is an overlay showing the wind circulation with the wind barbs, you know, those arrows that are moving are indicating wind directions and intensities as they come closer together. And then you have the radar and the satellite over the continental United States, where you can see the clouds and the rain that's going on right now. But the colorful graphic is showing the sea surface temperatures. And where Ernesto is, you can see it pinwheeling there on the satellite. You have way up into the high 80s in terms of sea surface temperatures. Now, you only need 80 degrees to maintain or strengthen a tropical cyclone, so the water is more than warm enough, and the storm's moving fast enough where it won't upwell any cooler water and bring it closer to the surface over its track. It's moving fast enough to be clear of that scenario. So you would think that it would continue to fuel itself, continue to get stronger, but that hasn't been the case. And unlike the previous storms in this season that have developed into hurricanes, it didn't have that maximum, really quick, rapid intensification process that a storm like Beryl did. And that's because it's been encountering a lot of dry air and a lot of wind shear, which I'll show you in a minute. But the last highlight in this graphic, before I move on, would be the spaghetti plots that we included here. And those are the combination of all of the various model forecasts. So they're run, multiple times a day, and these agencies are, global. You have the European in here, you have the Canadian, you of course have the American models, but the fact that this grouping here, this tight grouping of model members, is so close together, and you discount the outlier. So I'm not sure which model this is at the moment, but that's definitely an outlier that somehow did not get the same data set input or just crashed as it was computing the solution. So that's why that line's going out relatively straight like that. It's always a sign that the model crashed. But the grouping of these models and the way that they're agreeing in the movement of Ernesto is something you don't see all that often once you get out this far, up here, once you get out toward the same latitude as Cape Cod, let's say. The grouping and cluster is still just as close together as it is over Bermuda. And that's a tribute to the modeling. I mean, normally you'd see models that are all over the place. The lines would be going and swirling and doing everything. But this is a good model agreement scenario, and we're pretty confident that Ernesto's going to take a track very close to this path. In terms of what I think is impacting Ernesto and what we have been looking at here in the Weather Center at Weather Co-op, I'm going to show you a couple of different images, and we'll take this one off so that you can see what I'm looking at here. All right, and then we'll go here. Okay, so this image that I'm pulling up for you right now is the high-resolution satellite loop, the latest satellite loop for Ernesto from GOES. And there are some telltale signs here when you're forecasting and analyzing a tropical cyclone that I'll point out to you and hopefully teach you a couple of things. I mean, that's one of our goals here at Weather Co-op, is to try and make you more informed about the weather and try and teach you things about the weather you might not know. And some of these things you may know, and that's great. Hey, I love it. But it's always great to know that we can give you so much information here because we have the delivery system and because we have the time to do it. We can go that extra yard for you. So early in this loop, we start at the beginning of it. You see that Ernesto overall has a bit of a misshapen look to it. And what I mean by that is that out to the east of the center, it's pretty easy to pick out the eye there, out to the east of the center, the storm looks very well organized, has a great fan motion to it, and that fan is indicative of ventilation. So as the heat rises through the center of the storm and shoots way up into the atmosphere, eventually it cools, it kind of flattens out, it can't rise anymore, and it fans out in a beautiful display of cirrus clouds. And that's what you see with this fanning appearance. Well, out on the west side of Ernesto, it looks really jagged, really broken apart, and quite open. We'd call this a somewhat open circulation. And that is because Ernesto is interacting with dry air, extremely dry air, that is being ingested, the term we use, into the storm. And warm air ingestion will inhibit or work against the development of convection. So it's it's like an Achilles heel, I guess, right? That can keep a cyclone from getting stronger than it would given an ideal situation, in a scenario. It has plenty of warm water. We already looked at that. That's fine. But the dry air has been hurting Ernesto from the time that it was a tropical storm over Puerto Rico. It was pulling in dry air, and it was pulling in Saharan dust. And for those of you that don't understand that, trust me, you can go down a rabbit hole real quick reading about the impact of Saharan dust in the formation of tropical cyclones. There are times when it actually works in favor of storm formation, but most of the time it works against it. It acts as another condensing nuclei. Sorry, I didn't mean to go that scientific on you. But condensing nuclei will work against the process of droplet formation, so raindrops and coalescence and collision, things that you need to develop thunderstorms. The Saharan dust can act against that. And if you have enough Saharan dust in the atmosphere, it can really cut down the way that a tropical cyclone can intensify. So Ernesto was dealing with a little bit of both of those factors, and it kept it from really maxing out and becoming like a Cat 3 or Cat 4 hurricane in the short time frame, like some of these storms that we've seen recently have done. As the loop continues, however, and we get toward the end of it, which is now, you can see that the center of Ernesto, the rough center, actually looks like it becomes better organized. There's rapid thunderstorm development. You can see the bright white, the marshmallow puffs, I like to call them, that wrap around from the east side of it and gradually get back around the entire eye. So it becomes a little more symmetrical, and you can see that outer banding beginning to populate outward. It's not where it could be, but it does look a little bit more organized than it did 12 hours ago. The only issue that I see now is that Ernesto's also working against some wind shear. And by the height of these clouds, given the satellite view, I'd say this is somewhere around 25 to 50,000 feet, maybe a little bit higher, where you can see that there's some type of wind motion here that's coming from the southwest to the northeast, and it's ripping the outflow up and away from Ernesto, a lot faster than it normally would go. So there is some shearing impacting Ernesto also, and that's going to inhibit its development. Typically, it doesn't want any other wind messing around with it. It wants to create its own wind. And when you see that happening and you see it getting ripped apart like that, that's usually a sign that it's going to have a tough time moving forward. Next image that I'll throw up here is this is essentially a water vapor, one of the many water vapor images, but this one's dialed in to look at the dry air just as much as it's looking at the water vapor itself. You can see by the gray and the white, and then transcending into the blue and the green and the red. Those are the water vapor areas. That's the wet part of this image, if you will. The orange and the aubergine and the brown, all of those are indicating the dry air and the dusty air. So in this image, it's a long loop. This was from when Ernesto was first classified as a depression all the way up through the current frame. And you can see it here as it cleared Puerto Rico and the Dominican Republic, Hispaniola. It moved into another pocket of dry air. It was already working against a pocket of dry air as it approached Puerto Rico, right there. And then once it made it past that, it did intensify, right? If you go back and think about it, it did intensify rapidly. You can see it wrapping up here. But then, pow, here is this other element of dry air that worked in. And you could actually see the dry air eroding the western edge of the storm. So that's kind of the scientific background as to why it's performing or not performing the way it is right now. So finally here, in terms of these images, I'll show you this. This is more of an infrared type of image, but it shows Ernesto circulation. And again, right toward the end there, it does look like it's getting a little bit more symmetrical. But you can see the dry air being sucked into it. Literally, that darker area is drier air. This kind of flat, grayish looking air, it's not really air. This is the actual dust, Saharan dust being caught in the image. So that's Ernesto. Down to the bottom right of the image is what could develop, not really there yet, but could develop into potentially the next tropical system we'll have to keep an eye on. This is a very strong tropical wave that ejected off of Africa, and that little cluster of dots there are the Cape Verde Islands. That system, we're going to have to keep an eye on that because it looks pretty healthy. It did have some motion with it already. It just has to fight its way through that initial plume of Saharan dust to see if it has a chance moving forward. And that's about it. That's an update, very in-depth discussion on Ernesto and a lot of the things we wanted to cover here. Erica will be on shortly.
Well, actually...
wait, Erica.
Hello?
How about, that's shortly.
Hi. Hi, guys. Did somebody say Erica? All right.
Somebody said Erica.
Somebody did. Let's go back
Hey,
to
Erica.
this right here, this graphic. Let's pull this up. Hi, guys. Okay. Let's pull this up right here.
Okay.
Okay.
I'm going to pull
I believe,
this up.
okay.
Wait, you don't know what this is yet.
Yeah. I believe we created this for you earlier. Let's just go ahead and make sure it might be down, farther down. Mm-hmm. Okay, 1 second. Hey guys, just getting this prepared for Jay. Okay, there we go. So this is a great one right here. This is a great product, and I think all you need to do is just get this one going for everybody.
See, Erica loves this computer that we have at Weather Co-op,
yeah,
and she is a master.
Let's not tell them about it. It's our secret. And so here we go. So talk about this because I know you did mention it. Like one of the things we want to make sure is that we're delivering on everything we're saying. So because we are approaching weather from a global perspective, hi guys, because we're approaching it from a global perspective, we've got to really, I always tell people, you know, everything connects to each other. Like we always think we're so like isolated in our worlds. We're like, oh, we're on the West Coast. Well, no, we're not. We're on the continent of North America in the country of the United States.
One big
so
weather.
when I'm looking at weather, I have to look at it from where we are and then kind of just how it's coming, where it's going, etc. So, Jay, something you mentioned earlier, and I think everybody would love to hear more about, was the genesis of these waves, and then discuss maybe the Saharan dust. I do believe you also may have had another product in there, but I don't know. Just take a look. I think this is a great product.
Yeah, this is a interesting 120-hour combination product that has a lot of layers to it. You can see the obvious radar and satellite inclusions there, but we also have the wind, and this is, you know, it's set at a height in the atmosphere where it's denoting more of the steering winds. So like over the Great Lakes, for instance, in the Ohio River Valley, you can see the impact of that trough really coming down, and there's another upper level low that's spinning down, crossing over the Great Lakes today. You can really see that as indicated by these wind barbs at this particular height. And then around Ernesto, you can see some of that higher level wind influence that is shearing the top of Ernesto off up toward the northeast. You can actually pick that out right there. But one of the other inclusions in this particular product is the Saharan dust. And you can see it slightly, you know, just to the west of Ernesto right now, over toward the east coast. But as I put this into motion, you really get to see it here. So this is our view over toward Africa as we traverse the Atlantic in 4 seconds. And this is showing the migration of these, in this time of the year, it's really starting to ramp up. These massive thunderstorm complexes, like MCS complexes, that move across Africa, caught in the westerlies, eject off the western coast of Africa, and it's called Cape Verde season because those are the Cape Verde Islands there off the coast. And literally these waves, as they eject, they're so strong, have a great chance to strengthen into tropical depressions and tropical cyclones because of their location, because they really, initially they don't have a lot of atmospheric working against their development, but they do have the issue of the Saharan dust. And it makes perfect sense because the area of Africa that the storms are propagating from is more of a desert region initially, until you get to those countries, those small countries and areas on the far western coast. That's a little bit more mountainous, but initially it's just plowing across the desert. So it's billowing these dust clouds out ahead of them like haboobs, and they're pushing off the coast with the complexes. So a lot of dust gets thrown out into the Atlantic this time of the year. And if the thunderstorm complexes get caught in that dust, and there's an awful lot of it, sometimes it will suppress them and they won't end up developing into anything. And one of the things we watch is what happens here and how much dust is out there at any given time. And also the wind directions. If there happens to be any odd shearing elements in that initial 1,000 miles or so off to the west of Africa, where some of these waves are so strong as they push off, they have a chance to almost develop as soon as they get out over open water. You'll see it right away. There'll be an indication, as you can see. I mean, I'll put it out there. Whether or not this is going to stay, I don't know. But for the time being, you can actually see just a little bit of a counterclockwise swirl here within this complex that pushed off. I've seen this, 100 times if I've seen it once. When you see that slight little bit of counterclockwise spin there, that can be the beginning of a low pressure element on the wave. And that's all you need. That's the key element there. But we'll watch this. And of course, moving into September, we get to the peak of the season. We're going to be watching this area a lot more intently here at Weather Co-op. And whatever happens, we will certainly pass that on to you. And that's it. That is really, you just had tropical forecasting 101 right there. We will be back shortly. Erica will be back on. She will run through the U.S. forecast for you one more time, give you a look at your weekend, and also give you a look at anything that might happen to be firing up across the U.S. right now. But thank you for being on this. We appreciate you here at Weather Co-op. Please follow us on all of our media outlets. We have Twitch and YouTube and Facebook and IG and X. And have yourself a great afternoon.